Hello everyone, I am Nandini. Today I will be presenting you to our project RLVO, Realign Language to Visual Objects with an Agentic Workflow. This is a research paper that has been already worked by some people, and these are the people that have been worked on this research paper. And we are now working on this research paper for our further improvements. And the challenge: bridging language and vision. Language based object detection LOD aims to connect objects in images with natural language expression or natural language description. There are two types of LODs. That one is traditional LOD and the other is modern LOD. The traditional LOD relies on human unauthored description, which are precise but which are nothing but they are accurate and they are also limited in scale. And whereas modern LOD uses vision language models (VLMs) to generate description for massive sets. Then this is where the problem comes in. And the problem with this VLM or modern LODs is hallucinations. VLM often create inaccurate description leading to hallucinations that are nothing but wrong categories, incorrect attributes, and the wrong relation between the attributes. And the challenge: VLM hallucinations. The language based object detection LOD aims to align visual objects with language expressions or language description, while vision language based models VLM help scale training data by generating human like expressions. They often suffer from hallucinations. These hallucinations leads to incorrect object description, that is nothing but name, color, shape, deteriorating the vision language VL alignment quality. This specifically problematic for small objects or when text prompts are unspecific. And let's take an example like when we are giving a prompt, what is the object in the red box? And there are many red boxes. The model can identify the many red boxes in this so that it will give the response as the object is a blue and red hat worn by the young girl, whereas the model gives a response which is incorrect. So that we are going to rewrite this prompt as, and we are going to extend the VLM with extended crop. The prompt is that the same prompt, and the response is that the object is a flag with a design that resembles the Union Jack. And this is the correct response that the model has given without any hallucinations. And this is also the similar example introducing the real LOD and agentic workflow. And there are three steps of the workflow. First one is planning, tool use, and reflection. And the planning is nothing but determining description correctness and the next action that has to be done. And the tool use is nothing but adjusting prompts, image edits, and queries, VLMs and LLMs. And the reflection is nothing but LLM checks for the results and it is going to feedback the refinement of the model or the description. And so that we are going to give the raw expression to the real LOD so that the real LOD works on planning and then use for test tool use and then go with the reflection. If the reflection that the model has given, that is it is nothing but the result, if it is correct, and it is going to realign the expression, and this cycle iterates until the language expression accurately matches the visual objects. uh, Five stages for action. The LLM planning stages access the description accuracy and decides on specific action based on five predefined states. Those five predefined states are right, wrong, uncertain with category or attribute, and uncertain with relation or accessory, and uncertain with location or behavior. And when the predefined state was right, the description is correct. So the action would be taken was stop, and when the predefined state was wrong, the description is incorrect, so the action would be taken was rewrite using LLM. And when the description was require some specific focus, so the action would taken with what LLM VLM cropped object view. Uncertain relation or accessory needs broader content, so the action that was taken was VLM with extend crop. Uncertain location or behavior, so for this state, the focus is was on action or placement. So the action was taken as VLM with highlighted border or text. Real data, a high quality dataset. The real LOD process was used to create a new and high quality dataset. Initially, we have 188K images yielding to 1.4 object language pairs, and we have 473 low score pairs for realignment. So the real LOD successfully realigned 307K of these pairs. Final dataset, 1.18 million high quality pairs suitable for training robust LODs. And the realignment process addresses six main types of errors. And these are the six main type of errors. They are category, attribute, accessory, location, relation, behavior. And this is a graph of these errors occurrence percentage. The category and attribute errors were the most common. Conclusion and future work. Real LOD effectively refines language expression for real objects, addressing VLM hallucinations and significantly improves LOD performance. This genetic agentic workflow offers a new paradigm for scaling high quality of data, and we are going to perform some future work, and they are multimodal reasoning. Integrate multimodal reasoning to future reduce hallucinations in generated description. Video based LOD. Expand real LOD to effectively handle language object detection in video sequence. So we are going to take a video and we are going to frame that video as a frames, and we are going to generate the description from those frames. And feedback loops. Incorporate user feedback mechanism for continuous improvement of data set quality. And the next one was real-time integration. Develop real LOD for real-time application, enabling instant language object alignment during live object detection. This is also called as proctoring, which will be more helpful when we are going to attend an online exam. So, for instance, we have performed an implementation of our model, and we are given an image to the Lava chatbot so that it has given a description of the image along with hallucinations. So that this description is given to the our real LOD caption refiner using we are used Flantify model, which is small for instance and it is available for free. So that we have performed a small Python code, and this model is going to take the prompt along with the hallucinations, and it is going to generate the response without any hallucinations. So that when we are given a prompt of this, and it is going to generate that response, a man is ironing clothes while standing on the back of the moving car, and this is the response that it has given, that the model has given without any hallucinations. Thank you.